Welcome to the Purpose Nation podcast, inspiring conversations with Christians in science, technology, and industries of the future. For more information or to make a tax-deductible contribution, visit purposenation.org.
Greetings and hello, this is Brad Cooper with Purpose Nation, and today I am so thrilled to have on the show a good friend, Professor Jonathan Feng. Welcome, Professor Feng. How are you doing today?
I'm doing great, thank you.
Okay, great. Thanks for joining us. Just looking forward to a discussion about faith and science and some things that I know that are near and dear to your heart, like dark matter and maybe some other deep topics like the meaning of life or the meaning of the universe, why we're here. A few simple things like that maybe we'll get into a little bit today, but just thank you for joining us. Before we even get started, I want to tell you a little bit more about Professor Feng's impressive background. He's a professor of physics and astronomy at the School of Physical Sciences and the University of California, Irvine. And Professor Feng studies theoretical particle physics, astroparticle physics, cosmology, a few really easy things like that. He earned his AB in physics from Harvard, his MA in math from Cambridge, and his PhD in physics from Stanford. So just a few lax schools that a few people might have heard of, kind of a slacker there. Right. So I'm kidding. Obviously, a very impressive, background. So he joined UC Irvine faculty in 2001, professor and chancellor's fellow in 2006, and he's been recognized many times with grants and fellowships, things. Also a frequent speaker at conferences, and he does travel around and his work, and he's been covered many times in places like USA Today, Science, Nature, Washington Post, some places you might have heard of. And on top of all that, he's a devout Christian, and he's also been on some of the front lines with the discussions and the intersections of faith and science. And as a writer and speaker, and he spoke at the Veritas Forum, which is actually how God connected me with him. So, Professor Feng, starting right in on what you do and physics and being a physicist, what exactly is a physicist anyway? What are some of the things you do? Talk about maybe some of the specific fields you work in.
Yeah, great. Well, thanks, Brad, and it's a real pleasure to get to talk to you. Physics is sort of a broad field, but basically what we're trying to do is sort of understand nature and physical reality at the deepest level. And so this covers a lot of things. Some of my colleagues study sort of the physics of biology, the physics of life. Some study the physics of materials, so really trying to understand things like what the world is made of. So you go to like atoms and the nuclei and then how they combine to form materials, and that leads to all sorts of things, including lasers and computer chips and things like this. And then my area is sort of linked to cosmology, or the study of the universe as a whole. And so what we try to do is delve down even deeper beyond atoms and nuclei to the sort of most fundamental particles that make up everything we see, and also relate it to the structure of galaxies and even larger things like galaxy clusters and things like that. So it's a very wide-ranging field and has many different subfields within it.
Also, as I understand it, there are sort of people who focus more on theoretical kinds of research, experimental projects. Then you obviously have, I would say, people in more applied physics that are doing engineering and kind of hands-on and other types of industries. Is that sort of a fair
that's exactly
classification
right.
as well? And now you're more on the theoretical side, I guess?
Yeah, that's right. Each area has sort of two camps within it. So within, say, particle physics, which is my area, then there are theoretical particle physicists who come up with ideas and build theoretical and mathematical models of things and predict things. And then experimental, say, particle physicists who actually build experiments to go out and explore and see what they can find, possibly verifying some of the theoretical predictions, or in many cases just discovering completely unknown things. And then, theorists then have to try to explain that. Yeah, and there are people who are in applied physics who are very much linked to, technology and actually building things that will go out in the marketplace.
Right. And they're all tied together, as you said. I mean, so there's the theoretical sort of hypotheses. You've got people testing and experimenting to kind of confirm or the hypotheses or bring us in other directions. And then once we sort of have some knowledge or new knowledge or discoveries, and then there are also people who take those findings and maybe apply them to things like you said, like engineering and technology and other fields. Just in general, I would say people may not appreciate this, but I'm a big fan of physics, as you know, but there are some pretty amazing discoveries and some very practical things that physics has brought us, over the past 50 to 100 years in particular. I mean, what are a few of the things that people should know about that through the work that you're doing and other people have done in the past have brought us?
Yeah, well, so two of the great discoveries in the last 100 years or so are quantum mechanics and relativity. Quantum mechanics, just emerged as an attempt to just understand fundamentally what's going on at the sort of smallest levels, at sort of the level of atoms and things. But, now it blossomed. I mean, almost everything that people use in electronics these days is built on quantum mechanics.
Right.
So that's
right.
a huge thing, from your...
Yeah, little things like the internet, maybe computers, cell phones.
Exactly.
The GPS,
like
all kinds of things, right?
Yeah, and GPS is a great example, actually, that you mentioned. It's, that actually works because of general relativity. So Einstein basically figured out that the way gravity works is described by a theory called general relativity. And the fact that our cell phones can sort of place us to, within, 10 meters or something, is entirely based on general relativity. If we didn't know general relativity, there'd be no way all of our sort of positional locations and times would go off in a matter of, minutes.
Right.
So that's completely
based
on
and things in medicine, MRI. I mean, there's so many other things that people, again, sometimes we take for granted, but really at the heart of it are some of those key discoveries that you talked about over the past century or so. So that takes us back a little bit. So, how you got into this. So, as you're a kid, you could have, maybe a teenager or something, said, hey, maybe I could be a rock star, or maybe I could play the NBA. You know what? Actually, physics sounds kind of cool. I think I'll do that.
Yeah.
Take us back to that point, or if there was one point, or if it was sort of a series of progression that led you into your field.
Yeah, no, absolutely. So I grew up in a pretty academic family. My dad is an engineer and was a professor for some time, and then worked as a national lab for much of his career. My mom was a doctor. So I always grew up in a family that was both definitely Christian and also definitely scientific. When I was young, I loved math. Math was my thing, and for a long time, my two great loves were actually math and music. I played trumpet and did that for all the way through undergraduate and graduate school years.
Okay, so not quite the rock band, but I knew that there was some music in there somewhere. Okay. Math and music seem to go together, I think. But,
right.
Okay.
So my dream wasn't necessarily to play, on the Los Angeles Lakers, but more to play in the Chicago Symphony Orchestra. That was sort of the music side. But as I went to college, I think my love for math grew. And then an interesting thing happened when I was doing my undergrad years. I went to a meeting for prospective math majors and talked to this very old, famous mathematician. I said to him, I'd love to do math. Can you tell me about the career? And he said, well, a couple of things you should know is that math is something that's often done by yourself. You write papers by yourself. You think by yourself. You go years just working on a project by yourself. And so you should be very comfortable with being sort of lonely in a professional sense. And I thought, that sounds terrible to me.
That's a great sales pitch, huh?
Yeah. I tried to do something collaborative, and I looked around, and theoretical physics was very mathematical, but at the same time, people usually worked in groups of, 3 or 5 or something like that. And that actually made a big difference. So then I started thinking more about physics, and of course, grew to really love this idea of, it's very based on hard calculations and mathematics, but at the same time, it's like a puzzle. You're trying to figure out the world, and it's not just simply coming up with structures, mathematical structures in your head that are just interesting from a purely intellectual point of view. It's more, there's a goal. The goal is to describe reality. And if you have a beautiful mathematical structure, which is so elegant and wonderful, but it doesn't describe anything, that's not really worth much in physics. and I appreciated that goal. And I think it probably, the connection to understanding God and God's mind and things like that was not lost on me. That was also something in the back of my mind as I was thinking of moving toward physics.
Okay, and so a pretty heavy-duty school work, and all the way through PhD. I mean, is that
Mm-hmm.
typical for someone who goes into a career in physics, that you're probably looking at definitely bachelor's, master's, and in many cases a PhD? Is that sort of what people usually go, the path that they go through?
Yeah, so the undergraduate degree in physics can prepare you for all sorts of things because it's trying to teach you how to model the world, and that can be applied to things from natural systems to, we have people who go on and do finance, people who go to law school, medical school with physics degrees. But if you really want to do physics, sort of the traditional field, certainly you need an advanced degree, so you'd go and get a master's and most often a PhD. And then if you want to go on even further and do sort of fundamental research, typically you would do a postdoc. So you'd become a postdoctoral scholar after you got your PhD. And then that's sort of a transition period where you're heading off and being independent and doing things that you come up with on your own. And then after that, you would go ahead and get a faculty position where then you're really sort of on your own. But it's a long process. And it's something that you really need to love.
Right. Okay. So going back, and you mentioned this. So you mentioned you grew up in a Christian home, but how did that play in your career and your calling? And did the mysteries of science lead you to God? Did it play a part in maybe questioning some of your Christian upbringing? Talk a little bit about your Christian faith as it related to sort of your calling or your career choice.
Yeah. Good. For me, and maybe I'm a little unusual, but for me, growing up in both like I said, a scientific and a sort of Christian household, I always thought of those as going together very well. I remember still I was struck when I was in high school about to go off to college. The church we were in had sort of like a party or a celebration of some of the graduates. People started asking, what are you planning to do? And then it became evident then that there were some people in the church who really kind of felt science and their faith and evolution and their faith were really at odds. And that's kind of one of the first places where I thought, oh, wow, that's an issue. I didn't realize that.
Right.
And so for me, they kind of were very, not just consistent, but kind of, motivated each other. And so I think in my career, when you do science, of course, there's scientific reasoning, and when you're convincing people of what you're talking about, obviously you need to give logical, rational arguments. But at the same time, the motivation for doing it, the motivation for what you go into, and then also sort of the day-to-day things. So, for example, teaching, I see that as a calling. I see that as a place in my workplace that has very much the impact, is impacted by my faith. So anyway, it's sort of it was not a big issue for me, but as I get older and I see more people who think that these things might be at odds with each other, I realize that for some people it is, and then for me it becomes important to sort of get the point across that they're actually quite consistent, and at least in my view of things, they really are synergistic. They really support each other and come together. And I know a lot of other physicists and scientists who think the same way. And so
Right. Well, yeah, we can talk about that in just a second. Shifting gears a little bit, going back to some of the specifics. I believe one of the areas that you're pretty involved with is dark matter, and maybe to some extent dark energy, and people hear those terms, and they've been hearing more about it in the news, and probably a little bit superficially, and maybe don't understand it. But so what exactly is dark matter, and if you could also dark energy?
Yeah. So dark matter is matter that's just all around us, but we can't see it. So actually a better name for it would be probably invisible matter. And so we believe that there's this matter which is in fact flying through our galaxy, through the Earth, through us, even our bodies, which is not made out of protons and neutrons and electrons. It's not anything from the sort of classic periodic table, but which is nevertheless matter. And the reason we are quite sure it exists is that we see its effects from its gravitational pull. And it pulls normal matter because it interacts with gravity, and explains a lot of the data that we see on large scales. It explains why our galaxy spins around at the rate it does. It explains how the universe is expanding at the rate it is. And so that's what dark matter is. And it's in some sense, a placeholder name. We'd love to figure out exactly what it is, the way we know what an electron is. We know what the charge of an electron is. We know how heavy it is. These sort of things we don't know about dark matter. We just sort of know it's out there. And so that's one of the great mysteries in our field. And in fact, that's what I'm probably most associated with, is basically trying to identify dark matter. And dark energy,
just to contrast them, so dark energy is something pretty different, but if you could just at least address what that is, and I don't know if that's a big part of your work or not.
Yeah, so dark energy is another mysterious substance. It's actually the substance that is responsible for the universe not just expanding, but accelerating in its expansion. And so we've discovered this about 20 years ago now, that there's this very mysterious effect where the universe is getting bigger at a faster and faster rate. And that's actually due to the dark energy. So right now, our best estimates, which come from a variety of sources, are if you think of the universe as a pie, the part that we understand well, the part that has atoms and electrons and things in it, is about 4 or 5% of that pie, just 1/20th. And then the rest, about 25%, is dark matter, and then about 70% is dark energy. And so dark matter and dark energy make up 95% of this universe we live in, and yet we don't really understand what they are fundamentally.
Right, so 5% is the stuff we can see and touch and measure, and 95% is stuff that we almost don't have a clue about.
Yeah, exactly. Yeah.
So good time to be in this field. There's lots to discover there. And it's not. I know you're obviously very confident that it's there. And there's some, but I would say it's probably the minority. There's some physicists and scientists who think there are a couple of other explanations, things like modified gravity. I mean, there's others that I know you're not real fond of, but I mean, if you could at least talk about some of the other possibilities as it relates to dark matter that could be causing some of these phenomena that we see.
Mm-hmm. Yeah, so the reason we think there's dark matter is because we see, for example, stars moving in ways that can't be explained if there were no dark matter. But this all assumes gravity, or more specifically, Einstein's general relativity. We have tested that to great precision in many ways, but there's always the possibility that maybe in some extreme circumstances, those laws are modified. So that leads to the idea that there's maybe not more matter, but actually that gravity is modified. So that's a well-known theory is called modified Newtonian dynamics, basically modified gravity. In the last, 10, 20 years, I think that's really fallen out of favor because there's so much information that keeps pointing to it being matter. And all that information is pointing not only to matter, but the same amount of matter. There's 25% of the universe figure I gave before. And it just seems rather coincidental that, if it was modified gravity, it doesn't explain why every single piece of information is pointing to the same number, same 25% of dark matter. And
right.
Also, there are other reasons. But so basically now I think that even the modified gravity proponents say, in certain cases we can explain this with modified gravity, but nevertheless there's a large amount of data we just simply can't explain that way. And so even the modified gravity people would say, if there is modified gravity, there still has to be dark matter. And
right. So let's say, you're right, and a lot of the people who are behind this are right, and we come to a discovery, and I want to talk about that in a second in terms of the experiments that are actually going on right now. But let's say we discover it, we prove it, it's there. What kinds of implications, and maybe we don't know, but I mean, what are your thoughts on some implications of what that would mean for us, in terms of either, additional questions it raises, things that it could lead to in further research, actual other practical things for the average person that might come about from discovering dark matter?
Well, okay, so yeah, this is like the thing I dream about. So discovering the dark matter is, of course, the first thing, but once you do, what could it mean? That's a great question. I mean, to give it just an idea, though, let's just try to understand what we're talking about. An analogy I really like is everything we understand in science, in physics, is 5% of the universe. That'd be like if you spoke a language with 26 letters and you only knew the letter A, right? So, I mean, think of the richness, the fullness of that language, which you were just completely oblivious to because all your words only have the letter A in them. And so that's kind of where we're at. I mean, who knows how rich and full it could be. One thing that we all try to do in physics is try to develop simpler, sort of unified pictures of what we understand. One of the great examples of this is in the 1870s or so, Maxwell unified electricity and magnetism. So, the magnet that's sitting on your refrigerator sticks there, and then you go outside and you see lightning, which is, electricity. And the amazing thing is those two things, which seem to be absolutely different, magnetism and electricity, are actually described by the same fundamental principle now. And so that's sort of like one of the holy grails of physics and science, is to find unified theories of things that seem very disparate. And if we understand what dark matter is, then we could actually start approaching this with at least all the phenomena in hand. Right now, it's hard to imagine unifying things when you don't even know what you're trying to unify with. And so that would be certainly one possibility. The other possibility, it's hard to project forward to applications, but basically when we started understanding electromagnetism, we started understanding how we could have radio waves and microwave ovens and visible light and lasers to play your CDs and all these sort of things grew out of that. And it's quite possible that if we find dark matter, we'll find some other dark force, so something that goes along with gravity and electromagnetism. And that possibly could have implications for all sorts of stuff, but it kind of requires us to figure out exactly whether that force is a long-range force or a short-range force, whether that force is strong or weak. There's a lot of things that we don't know, but if in my dreams I could imagine that this,
That's pretty exciting times. So there's some experiments going on right now. We had a visitor here at UCI that I attended that was talking about one of them in Canada, and some of these experiments are in deep mines. But could you just talk about a couple of the experiments right now that are, and there's the LZ, as I understand it, experiment that's going on, but a couple of them that seem to have a pretty good chance of finding it. The most recent experiments have done a fantastic job of finding nothing, which in themselves, as I understand it, were good because they help sort of narrow the possibilities of where dark matter might be hiding. But if you could talk about a couple of the things that are going on right now.
Yeah, so you know quite a lot, but just to provide some background, so for example, this LZ experiment, one thing people have done is, because dark matter clearly interacts very weakly, if it didn't interact weakly, we would have seen it by now. What people have done is taken detectors deep into mines, so maybe 2 kilometers underground, where there's very little other activity. There's no sort of cosmic radiation. There's nothing coming from anywhere else. It's all screened out. And they put a detector down there and just observe a tank of liquid or solid and see if something bumps into it and makes that liquid or that solid recoil. And there's these extremely sensitive detectors who are just down there looking for 1 or 2 events to happen maybe once a year. And that's right on the frontiers of direct detection. The other thing is people are hoping to make dark matter at colliders. So the Large Hadron Collider in Geneva, Switzerland, which was very famous for discovering the Higgs boson a few years ago. Another thing it can do is actually, by colliding protons with each other and making very high energy collisions, might be able to make dark matter. And so we're also all sort of very much interested in looking at that data to see what happens, whether there's some evidence of sort of making invisible particles, which are seen, well, they're seen in various ways. They're hard to see because they're invisible, but we see them because there's an absence of energy when we sort of expected it. And so those are 2 of the leading detection methods.
The way that I've heard some of these experiments described is just an amazing feat of human ingenuity and just the clean rooms that they need to make sure. And I think I understand that they're like most radiation-free places on Earth. I mean, if you brought a banana down there, somebody would probably grab you and tackle you and say, they're just trying to avoid. Is that right? I mean, they're so sensitive, and this dark matter is so elusive that the experiments are kind of overboard on what they need to do.
Yeah, it's just amazing. So, at this talk, as you referred to at UC Irvine just a week or two ago, the speaker, Art McDonald, the Nobel Prize winner, was talking about how to run this experiment down deep in the mind, they had to take, I think he said, 20,000 showers before, so every single person that goes into that area has to take a shower because they're entering a clean room of, incredible cleanliness. And so that's one indication. And yeah, it's a really amazing thing. It's the things that people will do to go to the strangest places, deep in a mine. Other world-leading researchers at the South Pole, and that's just what's required to sort of get to the levels of sensitivity that is sort of frontier research at the moment.
Right. And so going back to your faith and the sort of intersection of science, for you personally, and it sounds like you're obviously a solid Christian, and you also had the interest in physics and math and science, and those two blended very well to you, and there really wasn't any kind of an issue. But as you said, and there are some people who maybe aren't Christian who are seeking, and they have this logical sort of scientific mindset and look at some of the things that Christians believe and say, I don't know if I can buy that. And then conversely, you have Christians who may look even derisively at science, or may be on the other end of the spectrum. For you personally, as you sort of explored these things and you've answered some of these questions, like you had some interesting questions at the Veritas Forum, from people that I'm sure also made you think about some of the compelling aspects for you that you see in science that point to a God. I mean, what are some of the things that you've seen that sort of reaffirm your faith?
Yeah, well, so I think a lot of the controversy comes from people who are sort of, I don't know how to say it, overselling or extreme versions of on both sides of the issue. But I think, for example, one thing that almost all scientists would agree with is just the wonder of the natural world. I mean, the fact that it's so put together in such a beautiful, elegant way. There are what are called symmetries. There are sort of mathematical ideas that lie at the heart of all of our understanding of the world. And I mean, I think if you get into science and you can appreciate these things, you begin to wonder, number one, just why is it like that? Why is it so elegant? Why is it so beautiful? And then number two, why is it that we're able to figure this out? And scientists, both scientists of faith and scientists or atheists, all wonder this. I mean, this is something that is really a puzzle. And so for me, that melds beautifully with the idea that there was a creator who actually was someone of, if you want to think of it in human terms, of incredible intelligence, who was behind this. And it melds beautifully with the idea that we were created and, given the tools and created in the image of this God who wants us to go out and understand things. And so I think for me, I think something that's often stressed is that faith and science lead to different conclusions. People really try to emphasize that when they're trying to break this down and say that there's a conflict. But for me, what they both point to is sort of this amazing beauty, this thing that I kind of wonder about. And I think actually that is something that's deep in the hearts and minds of both Christians, people of faith, and also scientists. That's something that we definitely have in common. And also the other idea is that, I think both communities think that there is a truth out there. I mean, clearly people of faith believe that there is an ultimate truth. Scientists believe there's an ultimate truth too. This isn't something that doesn't get a lot of play, in these sort of science versus religion wars, but right at the sort of center of their worldview is this idea that there is a truth out there and you can go and find it. And it's not like there is, everyone has their own truth. And if I went to a physics conference and said, well, okay, you guys think that the electron and the proton are opposite in charge, but not in my world. In my world, they're actually the same. That's just because I have my own personal opinion and that's just how it is. That would never fly,
Right.
And everyone is out there seeking something which, may be elusive, but they're quite confident that if they find it, they will convince other people that everyone's reality is this one truth. And I think that's a very important point that people across this interface all can agree on.
Right.
So
Yeah, and somebody like Einstein in particular, he didn't profess a particular religion. He just, like you said, he was seeking truth, and he used to say things like he wants to know the mind of God, and he wants to be able to see God, and
exactly.
Things like God is subtle, but he's not malicious. I mean, there's things for us there to find, and that there is this truth, and he spent his entire last half of his life, and there's lots of others, obviously. Yeah, and then they run into problems like, what happened before the Big Bang, or where did things come from if there was nothing? So these are scientific, potentially truths, and maybe some that are experimental. But yeah, you're right. It sort of gets into going in the opposite ends of the camp, and and there are some, as you said, there's some Christians who are probably too far on one end of the spectrum and not engaging and not looking at things from another's point of view, and then obviously there are people on the other end like Lawrence Krauss and Richard Dawkins and these people who are kind of new atheists or sort of on the attack.
Right. And
I mean, do you experience any of that, or has it been pretty good for you where you haven't had somebody sort of either challenge you or question your faith, or describe is there anything in your personal experience where this kind of has come to a head in any way?
Yeah. Well, just to go back to like Dawkins and Krauss, I think they did a poll about scientists' view of Richard Dawkins, and many thought he was doing a great disservice to science by the things he says. I think it's important that people realize that just as in any community, there are the extremists. He's kind of an extremist, and things that he says get wide play, a lot of publicity, and all over the media, but they're not representative of what most scientists think. So anyway, that's something that struck me when you mentioned those names. That's a nice preface of what I want to say about my career. People might think that in academia, in universities, in science in particular, there's this incredible animosity toward religion, Christianity, faith. I haven't seen that, and in part it's because I don't think Christians are as absent in academia as is typically thought. So, for example, in my department, and maybe a little bit unusual, but we have a large percentage of, a large number of Christians, but a fair number who are quite open about their faith and talk about it. And so I've actually not experienced too much of this sort of antagonism. I have experienced some, but it's interesting. It's often not really from my colleagues or my peers, but maybe from the public or spouses who have sort of a different idea of what I'm saying or what physicists are saying. But yeah, it's
encouraging. Yeah, and as you said, I think part of it is the media. Part of it is some of the spokespeople we see on television and shows. Occasionally, you will see someone, and me, just because I know, I'm like, oh yeah, that guy's a Christian. And I've seen some of his work, but it's not necessarily. I mean, you will see people who either publicly they go out either on attack, or it's more subtle. We know now that the universe was created 13.4 billion years ago, and this is how, and it's just a very assertive thing that subtly maybe pushes God to the side, or there's ways you can tell. So Christians are kind of they listen to people and they think, that guy. So it's that I think is what, in my experience, what people see. And maybe it's and I'm actually encouraged to hear from you that it's probably a filtered view. And so, encouraged in some way that it's not happening, but discouraged that that's not maybe always what gets presented.
Yeah, I mean, there is the aspect of consonance or agreement doesn't always sell books, right? So the people who, a lot of these people are authors, Dawkins, Krauss, Stephen Hawking is another famous example. And, a lot of things they say, I don't know if they're designed to sell the books, but they certainly help them sell the books. And so it's a little unfortunate. But there are other studies. There's this sociologist, Elaine Howard Eklund, who actually did a study where she went around, probably the most comprehensive study of the religious views of elite scientists. And so she went around and interviewed, I don't know exactly how many, maybe the top 20 research universities, and interviewed scientists from a wide range of fields. And it's a very fascinating study, and she has shown that there's a much larger percentage of evangelicals and religious people, either very actively, people go to church and lead Bible studies, like that, or just people who believe in the constants of these things than people think. So I encourage people, if they're interested to hear about this, go look up the work of Elaine Eklund.
Okay, yeah, I'll definitely check it out, and maybe I'll put a link to it on our website. Are there any heroes in particular for you, either growing up or now, Christians who were in physics or fields of physics, fields of science, or anybody that you, and not necessarily, it doesn't have to be Christians, but just people you looked up to?
So two of the great heroes in physics, Maxwell, I already mentioned. So Maxwell's equations are famous for describing electricity and magnetism. And another person who's maybe not as well known outside science circles, but is still incredibly giant of physics, is Michael Faraday. These are two people who worked in the 1800s and really basically developed on the theory end, Maxwell, and on the experimental end, Faraday, our understanding of electromagnetism. And they're kind of heroes to me, because not only was their scientific work outstanding, but these are two incredibly strong, devout Christians. Their faith went far beyond sort of, they were growing up in England, and so of course they were Christian. It was way beyond that. And you can read some of the things that Maxwell wrote as he was sort of untangling electricity and magnetism and developing his theory. And it was really, he was basically talking about finding the mind of God, but not in an Einstein way where God was a sort of amorphous thing that kind of was like nature, but actually really the Christian God of the Bible. And that's really clear. That's what he meant. He memorized large chunks of scripture, like some people say much of the Psalms he had in his head. This was someone who was just really incredible Christian, and at the same time the giant of that entire generation of physicists. And Michael Faraday is another one. One of the great stories I like about him is he got so famous, they asked him to be president of the Royal Society, which is like the pinnacle position in England, science in England, and basically in the whole world at that time. And he turned it down. He said, I don't think this is what God would want me to do. And that was like unheard of. It's like, how could someone be so humble to give up such a position? And this is just another person that I very much look up to, and sort of provides an example of how one should behave, both in their faith and also in their work.
Looking forward for you in your work, what do you see over the next maybe 10, 20, 30 years? Potential physics discoveries, obviously maybe it's something you're not as close to every day, but technology. What are some things that you're encouraged about that could be big discoveries that could help humanity, cure diseases, help us solve some of the big problems, whether it's energy or other things, either in your field or other fields? What do you see as some of the big discoveries that you might anticipate over the next 10, 20 years, 30 years? And then what are some of the things that you see that may concern you, if any?
Well, so these are big questions. These are good ones, Brett.
I saved the easiest questions for the end. So, we talked about dark matter, obviously. And you mentioned unified theory. How confident are you maybe that there is this unifying theory of physics that's going to tie all of these things together simply, or do you think it's just more complex than we'll ever be able to put together with just a few equations or something like that?
Yeah.
How likely do you think that we'll have a grand unifying theory?
So my view of scientific discovery is sort of one of the analogy I have in mind is someone who's hiking and wants to sort of conquer some mountain. And so what happens is we work really hard for years and decades and climb up to the top of a mountain. And when we get there, we've actually got somewhere, which is great. But then we look out onto the horizon and we see, there are a lot of other mountains I didn't realize when I was climbing up this mountain, and now we need to go find those. So I don't, see that people, and again, some of these people we've talked about, talk about the theory of everything, how we're going to find the ultimate theory anytime now. That I think is extremely naive, and there's lots of evidence that that's not what's going to happen. People have thought that for centuries, and they're always wrong.
Right.
So at the same time, I am an optimist in terms of scientific research. I do hope that we'll figure out at least something about dark matter, or the dark side of the universe, and that will be a peak, and that will be an amazing discovery to find new kinds of matter and sort of be able to maybe find new forces, new interactions that we don't know about. So I'm quite optimistic that that could happen in the next, like you say, 10 to 20 to 30 years. I hope it will. As for larger issues, it's hard then to see what the positives could be, but history shows us that they come out in funny ways. So again, going back to electromagnetism, when they discovered it, some minister asked, I think it was Faraday, what is this good for, this thing you discovered? And he said something kind of, he was being a little sarcastic. He said, well, I'm not sure, but I'm sure you'll figure out a way to tax it in the next few years. And of course, the entire electricity and magnetism runs our world now, right? So
Right.
he was right about that, and it took about 100 years for that to come true, but nevertheless it did. So it could be something like that. There are other things that have happened in a much shorter time period. So just the need for cooperation among scientists, that famously led to the development of the internet, because the web browsers and things like that were actually first developed at CERN in Geneva, because they needed to get ways for people to communicate very efficiently among thousands of people. And so that can have an impact on the way people interact and socialize and things like that. And I guess if I were to go to the last topic of what I'm worried about, it's sort of linked to that, which is just I see a sort of people in groups talking only to people they agree with. And this happens on every side of every spectrum. But I think it's really important that we all try to continue to talk with people who think differently from us, people who are from different places from us, because it brings perspective that you just simply don't get talking to people that are just like you. And it's much more natural to talk to people who are just like you, and I do that all the time, of course. But I try to realize that talking to someone who's grew up in a different place or has a different upbringing leads me to understand the fullness of the universe in ways that I just wouldn't be able to by myself.
Great advice. Even within, chemistry and physics and looking across disciplines, somebody can look at something that you've been looking at for 10 years and they come up with a completely different angle. I mean, the same thing for just any other issue, that whether it's in faith or doctrine or other great ideas often come from the outside and not in-house.
Absolutely.
And like you said, just a more kind of a civil tone and more being open to hearing from others and without making judgments, those kinds of things. So that's
exactly.
a great advice. So someone thinking of, a young person maybe that's out there listening, if they're sort of thinking about their career in physics or in science, what particular advice would you give them?
Let's see. Well, I would say, first of all, it's a fantastic career. It can lead to just wonderful work, wonderful colleagues, and so I would encourage them very much to pursue it if they find it's their passion. I would also say that it's a long road, and you definitely need to be committed. But the other piece of information I would definitely give is to try to find mentors. Find somebody who's gone down that road before you, who you can really not just talk to once every 6 months for 10 minutes or something, but who you can really go to and ask for insights, and who can really understand where you're coming from and can give you advice. This is not that easy to do. On the other hand, it is done by many people who are successful. And I read a poll recently, well, not recently, but a few years ago, which I thought was really interesting, of sort of college students. So this is at one particular stage, but I think it applies more broadly. They asked college graduates, several years down the road, 10 years down the road, and they asked them, how satisfied are you with your life, basically? And not just how much money do you make, but, how happy are you? How content are you? And then they asked them other questions, like, did you go to a 4-year college or 2-year college, a large college, a small college? Did you, what did you major in? Things like this. And all those answers had nothing at all to do with how content they were. The only one question they asked that was correlated to how content they were was, did you have a mentor in college? And if you said yes to that, your likelihood of being content 10, 20 years down the line was much higher. And I thought that was really interesting. So, I'd encourage younger people who are setting out, maybe trying to decide what their career is, go find someone in your church, in your school, in your university, who has gone down that road. And many of us more senior people are really busy, but at the same time, if we see some younger person who's really committed to doing something with their lives, we see ourselves in that person. and we will make an exception to, talk to that person and really try to help them. So, don't be rebuffed by it if you drop in the first minute and they don't have time to see you. Don't take that as and realize they're very busy, but I think many senior people very much like to help younger people because they see themselves, that was me 20 years ago. And so I'd encourage that. I think that's one of the best pieces of advice I could give.
That's great. No, that's great advice. I consider myself a geek or a nerd or whatever you want to call it, and so I'm a little more extroverted, I think, than maybe others who are kind of more deep into math and science. So, they're probably a little more reluctant to do things like that.
That's true too.
To reach out to somebody they don't know and say, hey, I'm thinking about this career in physics, Professor Fang. Is that something? What advice would you give me? So, and obviously, there are people maybe from your high school that graduated, alumni, or from if you're in college, college alumni. And like you said, vast majority of them, they're busy, but they are almost always at least willing to maybe do a quick call, an informational interview type thing to talk about what it is they do and what it's like to be a physicist. What do you do on a daily basis? And just so you can get a glimpse of, inside the life of what it's like. Obviously, it's a small glimpse, and it is, like you said, a long road ahead, but it's something where it's great advice to get some insights. And I don't know how much this played for you, too, but I think praying for God for that calling. He doesn't give everybody it on a silver platter.
Yeah, no,
Here
absolutely.
it is, Jonathan, you're going to be a physicist, but I don't think it works for most people that way. So it is a kind of a exploration both with your mind and with the Holy Spirit working through you to sort of bring you to your calling. But those are great things you can do to help it along.
I agree. Exactly. Thank you.
Well, so thank you so much for your time. Anything else that you wanted to talk about or wanted our folks to know?
No, I think we've covered a lot of great material, and I really appreciate your having me on. This has been a really fun conversation for me, and you bring a lot of insights to the things I was saying, so it's been a great conversation. Thank you.
Likewise. Thank you. Yeah, so, as you know, I'm pretty passionate about this topic and your field, and I do pray that more Christians like you, just anyone, but Christians in particular, would, explore these things, because we are, as you said, in kind of you're climbing mountains and maybe on, the verge of getting to some pretty amazing discoveries, and that, things that people have never done before or seen before, and just exploring God and who He is and His creation, how He did things, and, some things that may help others. And like I said, MRI is a perfect example. If you've had someone, as I have, with family members who've experienced cancer or things like these, there's actual physics discoveries that have helped, in chemistry and and obviously medicine and biology, where these are things that have very practical implications as well for people, in addition to being things where you can, as we talked about, explore God's creation.
Yeah.
Just thank you so much for being with us and blessing us with your wisdom and your time today, and your true servant leader in the church and with your field of physics and astronomy. So we just pray God will continue to bless you. Professor Fang, thanks for joining.
Thank you very much. Thanks, man.
Thank you for joining the Purpose Nation podcast. For more great interviews, resources, or to make your tax-deductible contribution to support our nonprofit ministry, please visit purposenation.org. This program is copyright Purpose Nation, Inc., a 501c3 nonprofit corporation.